All right, last section, well, 2 sections. We're going to cut it down a little bit. So in intermediate algebra, if you took it, it talked about simple interest, and we're going to get into compound interest. Which is A equals P 1 plus R over N to the NT. So if you get any interest on your banking in terms of a checking or a savings account, this is what they use. So P is the principal, R is the rate as a decimal, N is the number of times per year, T is time in years, and A is the amount in interest. Okay, there is one other one that you would need to know, and it's for continuous compounding. This is the optimal way to get your money, and it's a much easier formula. A equals P to the, here's our friend E again, RT. Okay, P is principal still, R is rate still, T is still time. So we're going to do some problems. So we're going to do $100 invested at 4% compounded quarterly after a period of 2 years. So the amount we started with, the principal is 100. Compounded, that's 4 times a year. 4 goes on the bottom, 4 also goes in the exponent, times the number of years is 2. Okay, so what I like to do is take it in as smart as the user typing it in, so it gets really confused if you type all that in. So 0.04 divided by 4 is 0.01. 4 times 2 is 8. 100 times 1.01 to the 8th. That's much easier to type into the calculator than the rest of that. And we get 108.29. So we're dealing in money, round to the nearest cent. So $108.29. Okay, so if we do a continuous compounding where we have $1,000 after 2 years, we're going to get A equals 1,000, E to the rate as a decimal 11 times 2. So again, I do recommend to simplify this before you type it into a calculator. I like to put E to the 0.22, hit enter, and then multiply by 1,000. And I get $1,246.08. So look at the difference between continuous compounding. Well, I guess this is a lot more money. Never mind. This is $1,000 versus $100. All right. So another type of problem you'll see is to find P. Needed now to get $100 after 2 years. Here's that 2 years again. At 6% compounded monthly. Okay, so 100 is what we want at the end. So we want to know if we're going to invest money now, and here are the stipulations that we have a 2-year term at 6% compounding monthly. How much do we need to put in now? P is our variable, 1 plus the rate is a decimal point of 6 divided by how many times we're compounding. Monthly is 12. 12 also goes in the exponent times 2. So again, I want to simplify as much as possible. So 0.06 divided by 12 is 0.005 to the 24th. My 100 still on the left. 100 equals P to the 1.005 to the 24th. Be careful about your calculator because there could be a rounding error, especially with what you're typing into MyMathLab. So you may want to do this in your calculator. 100 divided by 1.005 to the 24th. So no rounding. I also know how to use my calculator to put 1.005 to the 24th, hit enter, and I know how to do 100 divided by answer. So if you know how to do that, use that, and you should get $88.72. So realize that we're putting in less money. We're trying to get $100 total. Okay. 2 other types of problems you're going to see for 6-7 piece are for effective rates of interest. So we have one for n times a year. Okay, it's written like this. R sub e equals 1 plus r over n to the n minus 1. So very close to what's already on the inside. And then we have one for continuous. So r base e for effective rate equals e to the r minus 1. Very easy. Okay, so we're going to only do one of these problems. You have a couple on the MyMathLab for 5% compounded quarterly. Okay, so I'm going to get 1 plus 0.05 over quarterly is 4 to the 4 minus 1. So 1 plus 0.0125 to the 4th minus 1. And when I type that in, so obviously I could just erase this and make this 1. And I get 0.05095. And there's more decimals, but you'll see why I do this. This is looking for a rate. So if it's looking for a rate, we're looking for a percentage. So we need to change this and move this decimal 2 places over. So we're actually going to get 5.095%. So remember to change it. Okay, for 6-8, I'm going to post the notes for these, for the two problems. They're A through F and A through E on the two different problems, okay? So for number 1, before I get to number 1, let me write the actual formula that they give us. They give us P of T equals 500 E to the 0.02 T. Okay, so they give us the different pieces and they tell us that we have cells in a culture after time T has passed. K is that K constant that we've had before, so that's not anything new. And that 500 is an initial value. Okay, so that's all written in the description at the top of the problem. So 1 asks us to determine the number of insects at 0 days. So 0 days is going to give us that initial value of 500 insects. It asks, what is the growth rate of the insect population? Well, the rate is right here, but we need to change it to a decimal, or not a decimal, into a percentage. So it's going to be 2%. C asks you to graph the function. Because I'm not going to ask you to graph the function on the test or the final, put it on Desmos. It's probably the easiest way to do it. And then it's an A through D pick on MyMathLab. Okay, just so you can see what they look like. I guess this is A, B, C, D. This is number 1, sorry. What is the population after 10 days? Okay, so that's time. We're going to plug it in for T. E to the 0.02 times 10. Just like when I did continuous compounding, I'm going to do the same thing here where I'm going to do 0.02 times 10, which gives me 0.2. E to the 0.2 times 500 gives me, and it asks me to do to the nearest insect because we don't want parts of insects. We only want whole insects. So don't round, or don't give me 611.2 insects. I don't want 0.2 insects. E asks, when will the population reach 800? Okay, so we're going to make it 800 equals 500 E to the 0.02 T. Okay, so we're going to divide by 500 and we get 8/5 equals E to the 0.02 T. The only way to get the exponent down is to take the natural log of both sides. So you can either pull it down or cancel that out and then divide by 0.02. So I gave you that new website today that you could use as a calculator if you're not comfortable using your regular calculator for that. So the ln of 8/5 divided by 0.02, which I just looked at my notes. This is also 1.6. No, sorry, not that. The 8/5 is 1.6. So it is a nice number. Sometimes it's not. So you could put it in as a decimal. So I get 23 and asked to go to the nearest 10th, 0.5 days is how long it will take to reach 800 insects. The last question asks, when will the insect population double? So doubling the population means that we're going to get 1,000 insects. So 1,000 equals 500 E to the 0.02 T. So we're going to divide and get 2 equals E to the 0.02 T. Again, you can take the natural log of both sides and divide, or take that ln of E out, divide by 0.02. And to the nearest 10th of a day is 34.7 days. Okay, so that's number 1 on 6.8. And then number 3 is going to decay. So we're going in the opposite direction. So our new formula that they give us is a to the t equals a naught e to the negative 0.0244 t. But they tell us that we have 500 grams. So you're going to put 500 in for a naught. A asks, what is the decay rate? Okay, so the decay rate, we're going to take this right here and change it to a decimal. Or not a, I keep saying that backwards, sorry. Change it to a percent. So if we move it 2 to the right, we get 2.44%. But because we're decaying, we do need that negative sign. Okay. B, again, graph the function using a graphing utility. Again, I would recommend using Desmos. It's going to be on my math lab. Realize that when we're dealing with biology and those things like that, sometimes the numbers are going to get large. So I wrote down on this one, if I did it on my calculator, here are my window values. I would go x 0 to 100 by 10s and y 0 to 500 by 50s. So we're dealing in the first quadrant and we're dealing with some big numbers. So you may have to zoom way out to see what your graph looks like. C asks how much strontium-90 is left after 10 years. So you're going to plug in 10. A at 10 equals 10. E, nope, not 10, is 500. E to the negative 0.0244 times 10. So I get 500 e to the negative 0.244. When I multiply that out, I am asked to go to the nearest 10th because we're dealing with grams. So 391.7 grams. Okay, I'm going to skip D because it's going to be similar to the page or the question before, and I'm going to go to E. And we're going to go to a new page. Okay, so it says, what is the half-life of it? Okay, so when we said how long does it take to double, we doubled the amount. When we half-life it, we're going to divide the initial amount in half. So we get 250 equals 500. E to the negative 0.0244 t. And when we divide, we're going to get 0.5 or 1/2. E to the negative 0.0244 t. Take the natural log of both sides. Cross this out over there. I get the ln of 0.5 divided by negative 0.0244 equals t, rounded to the nearest 10th, and it's going to take 28.4 years for it to get to the half-life. So 1 and 3 are very similar. One is exponential growth, and the other one is exponential decay.